Welcome to the last part of this semester spring video. And I know we went through a few of these problems, and the biggest thing I want to just add before I get started is just that if you ever feel like you're deficient in any of these areas, remember there's still some videos posted on my website and where you go back and go through those reviews that would include additional examples as far as some of these problems. Now we're going to go ahead and now start working on solving vectors. And with the vector, we have two components. We have I and j, and they work slightly different than what you're used to working. So they have different properties, and the biggest thing we want to know is that this is ai plus b and the letter j. So we have these components that we're going to be working with. Now, when they want us to find 3v minus 4w, in essence, what they're asking us to do is something specific. They want us to know what is 3 times 2i plus 3j minus 4 times negative 9i plus 2j. Now, what we're going to do first is distribute. The nice thing about vectors is the rules will follow a lot of the same rules that we're used to working with math. So here at this case, this will be 6i plus 9j. And I'll keep this as a minus, and this becomes then negative 36i plus 8j. Now, what do we do from here? We're going to take our new vector and subtract them. Now remember, when we subtract vectors, you're going to be using this formula that's found inside your yellow sheet. a1 minus a2i plus b1 minus b2j. Now keep in mind, you may be looking at this and, well, which is a1, which is a2. This right here, this first letter, this is a1, this is a2. This is B1, this is B2 right over here, which means I'm going to first deal with these letters here first. So I'll have 6 minus negative 36 I plus B1, which is 9 minus 8 and J. So these become positive. I get 42I plus 1J. And there you go. That's my answer. So for this one, 42i plus j is the answer for this one. Lovely. Let's go ahead and move on to the next one. Now, the next one wants us to go into magnitude. Now, there is a formula for magnitude, and we're going to use it in this case. And they want us to go ahead and figure out what's the magnitude of v minus w. Now, the first thing we're going to do, we're going to subtract both of these. And in this case, since we're going to do v minus w, we're going to get one single, still using the equation, a1 minus a2 I plus b1 minus b2j. We're going to go ahead and use the same we're going to use the same vectors, or the same numeration, a1, a2, b1, b2, to go ahead and achieve this answer that's next. So we'll have 2 minus negative 9i plus b1, which is 3 minus 2j. So in this case, these become positive. This becomes 11i plus j. I think about it, 1j. Now what we're going to do, in essence now, is find the magnitude of this vector. And to find the magnitude of that vector, all we need really to do is just apply this equation, which is the square root of a squared plus b squared. So let's go ahead and do that. I'm going to move this right up here and do 11 squared plus 1 squared. I'll get 121 plus 1 square root of 122. You can see if you want to reduce that. And let me bring up my calculator so I can have it handy and ready in every case I do this. Because I'm trying to think which numbers could fit in there. Maybe 4 or 122. Those could be possible numbers that could go in there. So let's go ahead and do this. Let me clear this so I can quit. 11 squared. Okay. So let's do this. 122 divided by 4. Oops. It's divisible by 4. It's not divisible by 4. 122 divided by 16. No, not either. 122 divided by No, that shouldn't be there as well. So that's going to be your answer there. It's not really anything you could really divide it by, and then where we could reduce it. So there goes the answer 29. Now let's go ahead and now move on to the conic sections. Now the lovely part about this is that we just got done with conics. So if you're ever in doubt or have some want to refresh on the skills, there is some items that we could definitely look upon. Now this one right here is going to be an ellipse. And now you might be wondering, how do you know? How do you know that this is an ellipse? Well, let me point out some things to you. An ellipse requires a couple of items. Specifically, it's requiring me to have squares and x's and y's, and they're added. Okay, so that's how you know it's an ellipse. Not only that, but when we have denominators that are different, we have a sense that we have an ellipse and not a circle. So there's a couple of things there. Okay, so now that we all know that and are good at knowing ellipses, let's move on and answering this problem. We remove all that and talk about some general form. Now, first of all, I got to find the center. The center is found here. This is h, this is k. So in this case, my center would be 3, -2. Now, ellipses carry three measurements I have to look for. A vertex and co-vertices. So vertex, co-vertices, and foci to graph it accurately. Now, vertex is actually found from the a value. Now, this one specifically, now how do you know which one's the a value? The biggest one. This is going to be a squared because it is the biggest denominator. That's important to know. Denominator. That's very important to know. So this is going to be b squared. So there's typically three things we have to know. What is a squared? What is b squared? And what is c squared? And in addition, we have to know what a is, b, and c. And this is going to help us a lot in solving our ellipse, or not solving, but graphing the ellipse. So in this case, a squared is equal to 25, which a is 25. B squared is going to be equal to 4, b is 2. We're given this equation, c squared is equal to a squared minus b squared, to find out what c squared is. So c squared is going to be equal 25 minus 4, which is equal to 21. So this is 21. This is going to be the square root of 21, which is approximately, let's pull out that value, square root of 21, 4.58. So approximately 4.58. Now, I'm going to go ahead and start graphing. Now, as far as center, it's pretty simple to solve. But then you're going to ask yourself a question. Where is my major axis? Is it going to be this way, as far as the y? Or will it be x and be this way? How do you tell? It's going to come actually off wherever your major axis was. I mean, your largest denominator. Your a was specifically placed underneath the y, which means that I'm going to go 5 units up. My major axis is going to be on my y-axis, which means I'll go 5 units up. Here go 1, 2, 5. Here's a vertex. 1, 2, 3, 4, 5. Here's my other vertex. And then from here, let's do foci. Foci is 4.58 here and here. And then after that, we're going to go ahead and actually draw co-vertices. Co-vertices are going to go parallel to the x-axis. There. And then from here, we can go ahead and draw a nice looking ellipse. There we go. Lovely. We got an ellipse drawn. Let's move on. Now, this one right here is going to be a hyperbola. Now, you might be asking me, Mr. Sandoval, how did you know this is a hyperbola? Well, a couple of things. Just like before, if you have x squares and the x and the y, you pretty much have it narrowed down that either you're going to have an ellipse or a hyperbola. Now, this one is minus. Because of the minus, means specifically that this is going to be a hyperbola. And that's how I went ahead and got all that solved and answered. Now from here, you're going to go ahead and pull out some of the notes that you're allowed to use, and you're going to identify which way does this open. Now, because of the y squared being in front, we're going to have the format that this is going to open up and down. So let's go ahead and actually talk about center. Now with this one, since this one has no h or k, our center is going to be actually at 0, 0. Now this one also uses a squared, b squared, c squared, and then we also have to know its components, what a, b, and c is individually in order to graph this. Now because of that, this one is always on, this one follows in order. This one's always automatically a squared, and this one's always automatically b squared, which means in this case a squared is 9, b squared is equal to 16, a is 4, b is, I'm sorry, a is 3. Let's fix that. B is 4. C squared is going to be found using this equation, b squared is equal to c squared minus a squared. Slightly different. Now, in this case, b squared is 16. It's going to be minus 9. So we're going to add 9. Add 9. C squared is going to be actually equal to 16 plus 9, which is 25. This is 25, which means that this is 5. Now, the only other thing I have to do is find the asymptotes, and that's actually going to be found by using y is equal to a divided by b plus or minus x, which means that my asymptote lines are going to have, they're going to be, let's see, 3 over 4x plus or minus. So I'm going to draw two asymptote lines. So let's go ahead and draw my center first. And then also I have some asymptote lines which are b on either side. But after that, let me go ahead and draw my some of my asymptote lines. Up 3 over 4. Up 3 over 4. There we go. Down 3 over 4. Down 3 over 4. So let's finish this asymptote line, and now let's do the other one. Here, here. Here, here. Okay. Now, since this is going to open up, one of the things that we're going to have is we're going to have rectangular vertices that occur at b equal to 4. Now, they're affected kind of like horizontally in this case. Like, here's going to be my rectangle. See how this is 4 right here? That's how it's going to be affected, because the other measurement is going to be 5. Oops. All the way up. Oh, I passed this one right over here. Let me go back and undo this, because I've noticed that I did not do that great of a job. I passed. I was going this way. I should have stopped there. Hold on a second. Drew one of these slopes wrong. I wonder if this was causing confusion. Yes, I did draw one of these slopes wrong. The last slope. I went a little too much. The lines. And let's go ahead and redo this. Up 3 over 4. Up 3 over 4. Down 3 over 4. Down 3 over 4. Very good. Now we have something a little bit better. Something that's actually correct. Now from here, we're still going to go ahead and go by 4. But now when we draw a rectangular vertice, we're going to have this kind of rectangular vertice that gets formed. That's important because one thing is that our vertex is going to be here. Our foci is going to be 5 there and there. And our actual hyperbola is going to be generated off this measurement off there, off those asymptotes that is done here. Now let's go ahead and move on to question 32. Here's question 31. Okay, question, they want you to graph the following conic. Now with this conic in itself, this is going to be a parabola, so this one's going to follow Directrix. Now when you're looking at your notes, one of the things you're going to realize is that this one's going to follow, this one's going to open over to the side and actually open over to the right. But importantly to know that this general form is this 4 equal ax, which means that 4a is equal to 16 divided by 4 divided by 4. It's easy to find out that a is equal to 4. Now, why is that important? It's important because two things. A, my focus in this scenario is going to be 4, 0. Focus. And the other thing, too, is my Directrix. It's going to be x equal negative 4. It's going to be equidistant. Now, this one has a center at 0, 0. the vertex on this is going to be 0, 0. Not a center, but just a vertex. So my vertex is here. My Directrix, which is the asymptote line, will be here. And then after that, my focus is going to be 4, 0, which is right over here. Now after that, we're going to go ahead and, let me go ahead and collect two other points. So I'm going to take my focus points. Y squared is equal to 16 times 4. Y squared is going to be equal to 64. 60 square root. Y is equal to plus or minus 8, which means that at 4, 8, and 4, negative 8. Maybe two other points I could get out this parabola. So 4, negative 8, 4, positive 8. There is my parabola that gets formed in that case. Please move on to the next one, question 33. Now, question 33, and again, as well, will also be a parabola, but this one in itself has more information to it that we have to solve. Remember, this one, we're going to go ahead, this one does have a center, and one of the things that we're going to do with this one is that we're going to have this one, we have to have, let me write the general format for this one, so you get a better idea what we're doing here. General format for this one, we eventually want it to look like this. X minus h squared equal to 4a y minus k. I want it to look like that. And actually, you know what? Let me do this. Let me go ahead and select all this. Oh, not select all that. I want to select this in particular and move it. The reason why I move it is because I want to work underneath what I have here. Now, since I want to look at that, I got to remove this and this. So I'm going to subtract 3, subtract 3. I'm left with y equal to 3 is equal to 1 over 8. X minus 2 squared. I'm going to multiply by 8 and multiply by 8. That's going to cancel those out. But specifically, and I'll rearrange this so it can start looking more like what we have up there. 8 times 1 minus 3. Now, the nice thing about this is I have a lot of this solved. The only thing I really got to do now is figure out what this a is that generates this, and that's going to be pretty simple to do. If you're ever in doubt, just go ahead and make it 4a equal to 8 and find out what a is by solving. But if you solve it, you'll find out that a is 2. And this is 1 minus 3. Now the reason why this is important is that the vertex on this one is going to be at 2, 3, because this is h and this is k. And not only that, but my focus on this, well, a is equal to 2. My focus with this one, since this one opens up, means it's going to affect the y. So that means that in this case, we're going to have 2, 5, because all I'm doing is adding there. But my Directrix is going to be the line y equals 3 minus 2, which equals 1. So we have a Directrix here, 1, centers 2, 3, and we'll have an equidistant point here, which is the focus. Now, if I want to grab two other points, I can. And if they do, they'll ask you for that. But for the most part, I'm going to go ahead and draw it just because I want to save a little bit of time. But go ahead and make one of the points, make one of the y's. You go to the Directrix, and then you could get the other 2 points if you want something really, really clear. Like a really nice looking parabola, do that. All right, now let's move on to the next one. Write out the first 5 terms of the sequence. You know what? This is, let me make sure I have your same review. So hold on. All right, it looks like I have an older review, so we're going to go ahead and actually just we're going to write in the rest of these to solve them. So like in this case, we have 35. Question 35 asks us convert the parametric equation to rectangular. So now there's something called eliminated in the parameter. It actually gives it as a hint. This is essential because in order to convert, you have to eliminate the parameter. Now, what is a parameter in this case? T. You have to eliminate T. Now, how do you do that? You do it simply by making one of them equal to T and then put a place in the other. So like in this case, if I divide by this by 4 and divide this by 4, T is going to be equal to x divided by 4. Go ahead and put that in here. X divided by 4 minus 7. Voila. I've eliminated the parameter on my equation. Okay, pretty simple stuff, right? Well, yes. Question B, same thing. Eliminate the parameter. X equal to 7 plus t. Y is equal to t squared. What do I do? I'm going to deal with the top one equation. T is equal to x minus 7. Y is equal to x minus 7 squared. Now this could be a suffice answer unless you need to distribute it. Now if you find out that one of your answer choices is not looking like this, go ahead and distribute and see if it becomes it. And then you'll be able to be done with that. Okay, the very last one, see x is equal to 2t minus 1 and y is equal to t squared minus 3. So we're going to solve for t. Let me go ahead and write it over here because this is going to be more than one step. It's going to be a two-step equation. Plus 1 cancels out. X plus 1 is equal to 2t divided by 2 divided by 2. T is going to be equal to x plus 1 divided by 2. So when I place it in here, let's go ahead and go down a little bit, extend my page, and start eliminating the parameter. X plus 1 divided by 3 squared minus 3. Now you have in essence limited the parameter, but in this one looks a little bit messy, so you may want to go ahead and actually just combine some terms with this. So let's see. I won't go through all that just because you could probably make this a little bit nicer if you want. I won't go through all that just because I want to move on for this and be able to finish the rest of this review. Okay, now let's look at question 36. Now in your question 36 is asking specifically for you to go ahead and using your calculator. So I want you to using the calculator. So I'm going to have my calculator sketch the parametric equation given the model. It says remember to set your calculator parametric mode. Label all axes accordingly, indicating the orientation direction. Describe the graph. Now a couple of things that we're going to have to do here. First of all, we will change, just like it was saying, we're going to change this to parametric mode. So parametric, when we hit mode, go to the parametric is one side of the function. And then after that, you want to go into your window button. It's going to ask you to go from 0 to 2 pi. This value is already 2 pi, but if you're ever in doubt, go ahead and change it. And then after that, you're going to go ahead and describe this. Now we're going to change this from, I'm going to change it to -3 to +3, just because I want to get a better picture. Now the reason why I'm looking at this and describing it is that I'm seeing, in the first one, I'm seeing 2 t's. So let's go ahead and change this to -4, +4. Actually, I think it needs to be the other way around. Yeah, it should be -4, +4. Because this is actually going to form a circle from the looks of it. And this one's going to make -3, +3. It's going to make a kind of nicer looking graph when I do this. After that, that's going to be t sine, and t becomes now where you normally used to place an x, that's where it's going to become. And after that, we'll have 2 cosine t. So there's a cosine, and then let's go ahead and hit graph. And as you notice, you got this nice looking kind of it actually should be a circle, but we don't have it now. Something I want to point out to you. It says label all your axes accordingly. So when you're doing A, first thing you want to do, okay, so we're going to have this as X and Y. You want to go ahead and label some points here. So let's bring up the table to kind of make this look so you get a good idea what's happening here. Oops. Now, if you notice, I have the value 0, 2, and you want to put maybe some whole numbers here. So if when t is 0, you're going to have 0, 0, 2. So it gives you an idea as far as, let's see where else. You see how x goes to -2. But we're only going to go from 0 to 2. And see what you're going to do. 2. I choose that. And the looks of it, at least when you first see this, at 0, when t is 0, we have 0, 2. So actually, it should start this way and rotate around. Let me hit window. It's important. I hit window because I want to make sure that when I hit graph, go back in y equals to see if it does anything. No. I wanted to go ahead and regraph it. So let's go ahead and delete this, put t there again, and see if it does it. And pay attention. Okay, so this is what happens. This is important to know. Why? Because we're going to start this way, go this way, and hit back here. The orientation are these little arrows that tell you the direction that it's going. So that's the reason why you saw me move that around, because I wanted to see what was happening. The table will help me to go ahead and define how to graph it. At least it gives me an idea of where some of these points go. Because when you look at the table values, I was able to say that was 0, 2, and then when I got to close to pi, went back to 2. Slightly off on it, but that's kind of what occurs with this one. Okay, lovely. Let's go ahead and do the next one. I'm going to go back to window. Now this time, it wants me to go from -1. It gives you the t values, the positive one. So I'm doing question B. Question B in reference has this as the square root of 1 minus t squared. Now, if you have an older calculator, sometimes you may have to put parentheses all underneath there. Actually, it has the y at that value. Actually, it's just t. So let's go ahead and fix this. I'll put parentheses just to make sure, so you could, if you had a calculator and you wanted to be sure as well, just got to do these steps. I want to delete some of these other items I have here. And parentheses. Okay. So here, let's go ahead and graph this, see what happens in these value points. It's a syntax error. Probably something that enter 1 and y equals. Yeah, it has to be this. Oh, man. Hold on, there you go. There's my syntax error. Okay. Okay. I want to make sure, because I was getting a little too happy with it and I was thinking. Delete that. Right now. There it is. So with this one, if you notice, it started from this way and went this way. So in essence, this is what you have to graph. And it goes from 1 to 1. So when you draw this, this is 1, 1, and 1. This is x, this is y. Goes this way, starts this way, and ends that way. Orientation lines, there. Describe it. This is going to be a curve. It's going to be roughly a circle right here. So the way it touched. And the last one, let's look at it. Last one, let's go ahead and graph the very last one. Now the last one has us going from 0 to 2 pi again. So let's go ahead and do that. Change that to 0, change back this to 2 pi. And let's go back to the values. I'll leave those window the way it is there. So it's actually been working pretty well. Sometimes you may have to adjust your window, what I did at the beginning, just to make sure you have something that's correct. Let's clear this, 5 sine t, and the other one's 3 cosine t. Lovely. Let's hit graph and see what happens with this one. Oh wow, this is going to be an ellipse, stretching further than what my window is. So let's go ahead and change my window, especially my x. Let's make this into 6 and 6. Change this to 5 and 5. Let's go back to graph. It's a good looking graph right there as far as what's happened. This is definitely an ellipse. Now to graph this, you can bring up the table But in essence, it's going to reach heights of 3 and 5 because we know that this ellipse is what it's doing. So it has to do with the properties of trig in itself. When we look at the maximums and the minimums, remember cosine and sine functions read a maximum value of 1. So some of these. All right, so let's continue with the last graph of this one, and I think one of the things that we mentioned is that we were mentioning how on this one, the x, because of the way quadratics work and how they're 1, I think we had a maximum. The x was let me look. Yeah, the x was 3. So we're going to have a maximum of 3 here. Like this is 3 and then this is 5. This is -5, this is 3. So what ends up happening is that we'll have an ellipse that form this way. And orientation was pretty much, it was clockwise, if I remember correctly. Let me change, let me clear that, but I'm going to change the window slightly just so I can know what happened. So it is just by doing this. No, they want me to change something. Let me go ahead and make this 6.289. And now I hit the graph. Yeah, it went this way. So the orientation lines, let's put that back. Go in this direction. There you go. Lovely. All right, now let's move on to question 37. I want you to find the center and the foci. Let's see, center of foci of this answer. So they want me to find the center. So question 37, they want the center. They want the foci. So they want vertices and co-vertices of this ellipse. Now let's x plus 4 squared divided by 9 plus y plus 2 squared divided by 4 is equal to 1. Now a couple of things that we need to take from this. With an ellipse, first of all, this is going to be a squared and this is going to be b squared because of, remember, a squared is where we get our vertices from. So like in this case, a squared is equal to 9, a is equal to 3. B squared is equal to 4, which means b is equal to 2. C squared is going to be a function of these because if you remember correctly, c squared is equal to a squared minus b squared. So c squared is going to be a squared, which is 9 minus 4. C squared is going to be equal to 5. So it's going to be 5. It's going to be the square root of 5, approximately 2.82. So we have all that down. Now, why is this all important? Let's look. This one has a center. The center is going to be at -4 and -2. Now my foci, now this one is off. The major axis is the x-axis. Why? Because of this, the bigger denominator is right here, which signifies the a. So because of that, my foci is going to move from the center, specifically on the x. So I'm going to have, one of my foci is going to be -4 plus 3, -2, and the other one's going to be -4 minus 3, -2, which means I have -1, -2, and the other one's going to be -7, -2. Vertices, same idea. Actually, take that back. I actually found a vertex. So let's instead of having to erase all that and rewrite it, so let's go ahead and redo this. Call this the vertex. I found the vertexes. Why? Because I use a equal to 3. And if I want to find the foci, I got to use the same process. Now the reason why I'm using the x is because of the major axis. I'm going to do -4 plus the square root of 5. Oh, hold on, I don't want to do that. Which is going to be at, and the other point is, let's see, what was the point? -2. And my other foci is going to be -4 minus the square root of 5, -2. My co-vertices is going to follow off the y because of the location of it, so it's going to be -4, -2, plus 2, and -4, -2, minus 2. So we'll have -4, 0, and the other one's going to be -4, -4. And there's all the points of what they're looking for. All right, let's look at the very last one. They don't ask us to graph it, they just want us to find things. Now they want me to find the center and the radius of the given circle. So let's go back and remember that a circle has this format. This is for question 38. Circle has this format. Now what are we given? We're given this x squared plus y squared minus 6x plus 2y plus 9 is equal to 0. Okay, I got to get the equation at the bottom to look like this. So the way I'm going to do that, first of all, I'm going to subtract 9. There's two things I know I have to do. I have to get the constants on the right side, and then I have to complete the square afterwards. So x squared, and I'm going to order this. So let me start ordering. Minus 6x, I'm going to leave some space. Y squared plus 2y is equal to -9. Probably should have left a little bit more space here. And the reason being is because I'm also going to complete the square here. Now, we've got to get this magic number, which is achieved by taking -6 squared, squaring it. So we'll get -3 squared, which is 9. So when I add 9 here, I got to add 9 here. That's plus. And I'll do the other one as well. Let me do it over here. 2 over 2 squared, 1 squared, 1. Plus 1, plus 1. So this is going to be plus 1. Now we divide the b value by 2. X minus 3 squared plus, divide the b value by 2, plus 1 squared is going to be equal to 1. So first of all, my center is going to be at 3, -1. And my radius is r squared equal to 1, which means that r is equal to 1. There's my radius value. Okay, fantastic. Now, it wants us to find the equation of the circle graph below. So let me go ahead and do question 39 for you. Now, if you're looking at this review with this, let me go ahead and kind of graph what we see. This is what is graphed. I'm given a dot, given this, and given that this is 5. It doesn't go all the way around there, but pretty close. Now we're given the center. Center is going to be 4, 4, 4. Let me double check that again. 4, 4. So we know two things. And r is equal to 5. Okay, so if r is equal to 5, remember our general equation that we just came up from over here. I'll show it to you again. There you go. So if r is equal to 5, r squared is equal to 25. That's important to know. Because when building this equation, you're going to use this x minus 4 squared plus y minus 4 squared is equal to 25. That's your equation. Now, they want you to identify questions 40 and 40A and B wants me to identify. Get your Directrix. So 40A wants to Directrix. And focus for the following. So let's do A first. Y squared is equal to -8x. Now remember, the general formula for this is y is equal to -4a times x, which means that y squared, that means -4a is equal to -8. Divided by -4, divided by -4, a is equal to 2. -4 times 2x, a is equal to 2. The reason why this is important is that with this one, this is a parabola that's going to open over to its side. It's going to open over to its left. So with this one, since it's opening to the left, we basically have one that looks like this. This is how it kind of looks like. This is a general scheme of things. My Directrix is going to be x equals 2. My focus, this is going to be my Directrix because it's going to be on the right. It's kind of like something similar to this. And since it's equidistant, center being in the middle, there's no change to that. Signifies that my focus is going to be negative 2, 0. Which will be, no, not this. Actually doesn't, this is not a good representation now I'm looking at it. Why? Because this should be my focus. And the parabola should be heading up this way. This is a value of 2 on either side. Remember, it's equidistant to either side. Okay, lovely. So now let's do B and do the same thing. And we'll be done with this. Let's see. B is asking for us to do it now using the same thing. I want to find Directrix and focus. These values, our equation is going to be this. X squared is equal to 24y. Now this one's going to follow this format. 4a times y. 4a is equal to 24 divided by 4 divided by 4. A is equal to 6. So we have this. X squared is equal to 4 times 6. So with this, having our A in this case, now this is going to be a parabola that's most likely going to be opening up. And just I'm going to double check that. It is. So because of that, our Directrix is going to be the line. It's going to be now, in this case, Directrix is going to be somewhere down here. In this case, it's going to be y negative 6 for us. Y negative 6, y, because in your notes, y negative a. Your focus is going to be exactly, remember, our vertex is here, which means our focus is going to be here, 0, 6. Because being 0, that A in this case signifies that we're going to have 0, 6 as far as the focus. Excellent. All right, good luck on the final exam. Thank you.